Welcome back. We understood what are the different operators in Python as a part of our conceptual class. As a part of our practical class, we'll take examples for each of these different types of operators and see how they work. First and foremost thing is arithmetic operators. Let us go on taking example for addition, subtraction, multiplication, division, modulus, exponentiation, and also floor division. I am there in Python terminal. We'll get started with the addition. Let us try to add your favorite number. We have 4 plus 6 is equal to 10. Let's take some big numbers and see if it works. Yes, it does work. Let us take example for subtraction. We are subtracting 5 from 9. We get 4. Let us try to subtract minus 1000. We get 2000. So we are seeing different examples of arithmetic operators. We have seen addition and we have seen subtraction. What is the next? We'll see the multiplication. 6 into 4 is 24. Let us go for some big number. 4. We have 3120. And let's go for division as well. Let's say 8 by 2. You can see 4. 8000 by 100. Get 80. We have seen important arithmetic operators like addition, subtraction, multiplication, and also division as a part of the Python. Couple of other things are exponential, modulus, and also floor division. Let us see all of them. As we know, modulus will give us a reminder. 6 modulus 3, reminder is 0. 10 modulus 2, we have 0. 11 modulus 2, we have 1 as a reminder. So let us say 67 modulus 10, we get 7 as a reminder. This is how it works. Let's take some examples for exponential. 2, you can see 2 to the power of 2 is 4. Let's say 2 to the power of 3, it is 8. You can see 2 to the power of 4 is going to be 16. Let us take some other number. The power of 4 is 256. So we are multiplying 4 times. That is the reason we got result as 256. This is how you use the exponential. Now, one more thing called floor division. Floor division is indicated by 2 slashes. Floor division is almost like a division, except that even though we get a decimals and all those things, it will return to us the highest possible integer after dividing from some number. If I go ahead and say 2 to 2, the highest possible integer is 3. It will not give us the float, it will give us the integer, because 7 by 2 is almost 3.5. It is neglecting the 0.5. It gives the highest integer which is coming out of the division. Let's take some other example. Highest possible integer 8. Wonderful. We have seen all the important arithmetic operators. Next thing is assignment operators. We are assigning values to the variables and using those variables in our calculations. Let's see how to do that. Now let us assign x is equal to 2. Let us use this as a part of our calculation. So we'll say 2 plus x. It's going to be 4. It is getting the value for the x from already assigned value. Okay, because we already assigned it. You can do all the things from assigned values. Let us say x will assign some bigger value. Now if I say x minus 10, give 10, 20. X minus 10, it will give us 10 as the result. So we have seen addition and we have seen subtraction. We can also see x by 10, that also gives us 2. You can also multiply. You can see x into 3 is 60. Wonderful. We'll see some other examples like floor division and also modulus, also exponential also. X modulus 5 is 0 because we have 20 as the number which is assigned to the x. If you go ahead and say 7 Should give us the 6 because 20 by 7 is 7 twos are 14. So 20 minus 14 is 6. That is how it works. You can also 20 to the power of 2 is 400. Wonderful. This is how you are using the assignment operators. So when you assign a value to the variable, that will hold good, and you can utilize the same variables across different computations. Let us look at the comparison operators: equal, not equal, greater than, less than, and all those things. We will continue with the same. So if you say x is equal to 5, it says false. That is because x is assigned with the value 20. We can test all these things. X is not equal to 5, x is greater than 5, x is less than 5, and all these things you can try. Yes, x is more than 5 because 20 is more than 5. And let's say we'll just go with false. You can also combine these two things. It is less than or equal to 5. If I say x is more than or equal to 5, this is a syntax error. The way we should use this is it's true. Okay, these are the different ways you can use the comparison operators. You can use some logical operators, like we can have two variables and you can combine them like and, or, and not. Let's go ahead and see that how it works. As of now, if you see the value of the x is 20, we're constructing the statement where we're saying x is less than 10 and x is more than 11. Here x is not less than 10, x is more than 10, right? Let us change this and see what happens. Now it is true because we have used x is more than 10 and x is more than 11. In both the cases it is true. Let us try to update the above statement with R. In this case it is true because one of these statements should be true, then only this will become true. Let us go ahead and update this. It will be false because x is not less than 10, x is not greater than 21. That is the reason it is coming as a false. We can use not and see how it works. This is coming as true because both of these statements are not right. That's the reason it is coming as a true. If I go ahead and update this as 11, it will come as false because one of these statements is not true, one of these statement is true. We don't want both of these statements to be true. That is the reason we're using a not here. Wonderful. We have looked at the comparison operators. We can use the identity operators: is not. X is 6, that is false. That's true. X is not 6. X is not 20. If I say, then it will become false because x is 20. So we can use x is 20. It will give us the wonderful. We have seen most of the important operators we would be using as a part of the Python program. Please do practice all these examples. Thank you.